All right, let's jump right in. We're going to break down the absolute must-knows, the core essentials of Red Hat Enterprise Linux 8. So, whether you're brand new to this or just need a quick refresher, you are in the right place.
So, where do we even begin? Well, this quote right here is the perfect starting point. The easiest way to get your head around the Linux directory structure is to picture a giant filing cabinet. Seriously, the root is that top drawer, and every single thing else just branches out from there. Keep that image in your head because it's going to make everything else click.
Okay, so let's get into that blueprint. First things first, we've got to understand the layout, the very foundation of the system, and that is, of course, the file system. Right off the bat, you need to know about two different kinds of file systems. You've got your disk-based ones, think your hard drive or SSD. That data sticks around even if you pull the plug. But then you have memory-based systems. These are super temporary. The second you reboot, poof, it's all gone. The key difference here, the word you gotta remember, is persistence.
And see, this brings us right back to that filing cabinet idea. The entire system has this tree-like structure, and it all starts from one single spot, the root, which is just that little / symbol. Everything, and I mean everything, branches out from there. Once you get the hang of that, finding a way around becomes super predictable.
Okay, so we've got the map, we understand the blueprint. Now, how do we actually do anything with it? Well, it's time to open up the toolkit, and that means diving into the essential command line. Look, these commands right here, they're your absolute bread and butter. You're going to use them constantly. pwd tells you where you are. cd gets you somewhere else. Simple. But check out ls. Just typing ls is fine, but when you add -la, suddenly you've got this super detailed report with permissions, file sizes, hidden files, the whole shebang. And when you want to look inside a file, use less. Trust me, it's way better than cat for big files because you can actually scroll up and down.
All right, what about actually making and moving stuff? Well, touch creates an empty file. mkdir makes a new directory. Easy enough. When you're copying things with CP, you have to remember the -r option for directories. It's recursive, meaning it copies the directory and everything inside it. Now, the one you need to be really careful with is rm-rf. This thing is no joke. It deletes things forcefully and recursively. There is no undo, there's no recycle bin. You hit enter, and it's just gone forever. So yeah, be careful with that one.
Okay, now for a concept that trips some people up, hard links. A hard link is not a copy of a file. It's more like giving an existing file a second name. Both names point to the exact same chunk of data on the disk. It's the same file, just with two different names.
A soft link, or a symbolic link, is totally different. This one is a separate file. It's a tiny little thing, and its only job is to act like a signpost. It just holds the path to the real file. So it's not the data itself, it's just a shortcut that points you to where the data is.
And this is the best way to remember the difference. Think about it. A hard link is like having two different doors that lead into the very same room. If you get rid of one of the doors, who cares? The room is still there, you can just use the other door. But a soft link, that's just a signpost out on the street, pointing the way. If you tear down the building, the signpost might still be there, but it's pointing to nothing, an empty lot. That is the crucial difference.
Okay, so we know how to make files and move around, but who's allowed to do what? You can't just have a free-for-all, right? This is where we get into the rules of the road, the gatekeepers of this system, users and permissions.
The standard permission system in Linux is actually pretty straightforward. For any file or directory, you have 3 levels of access. There's the user, that's the owner. There's the group, a collection of users who get certain access. And then there's others, which is literally everybody else on the system.
So, that user group other system is pretty solid for most things. But what happens when you need something more specific? What if you need to give just Susan from accounting access to a file, but you don't want to make her the owner or add her to the entire engineering group? What do you do then?
Well, that's exactly what access control lists, or ACLs, are for. They're like a permissions overlay. They let you get super granular and add permissions for specific additional users or groups on top of the standard ones. It's all about getting that fine-grained control that the basic system just can't give you.
All right, let's change gears completely. We've been talking about all the static stuff on the disk, the files, the permissions. Now, let's talk about the living, breathing part of the OS. Let's head into the engine room and talk about processes and services. When you're dealing with services in RHEL 8, one command rules them all, systemctl.
And there's a really simple 3-step dance you'll do all the time. First, you use systemctl status to check on it. Is it running? Is it broken? Then, you use systemctl start to get it running right now. But if you want it to start automatically every time you reboot the machine, you have to use systemctl enable. So you check it, you start it, and you enable it to make it stick.
So what about making this system do things on its own, automatically? You've basically got two tools for the job, cron and at. And the way to choose is super simple. Ask yourself, does this need to happen over and over again on a set schedule, like a backup that runs every night at midnight? If yes, you want cron. Or is this a one-time thing, like run this script just once, tomorrow at 3 a.m. and never again? Then you want at. Recurring versus one-time? That's the difference.
Okay, last but definitely not least, we need to talk about how to protect all this. How do we keep it updated and secure? It's time to build the fortress and look at software and security.
For installing software in RHEL 8, you're going to be using DNF. And honestly, its best feature feels like magic. You know how sometimes you install one thing, but it needs 10 other little things to actually work? That's called a dependency puzzle, and it used to be a huge headache. Well, DNF solves that puzzle for you, automatically. You just ask for the main program, and it goes out and finds and installs everything else it needs. It's a lifesaver.
The firewall in RHEL 8 works with something called zones. The easiest way to think about zones is as a trust level for your network connection. For example, if you're at a coffee shop on their public Wi-Fi, that connection is untrusted, right? So you'd put it in the public zone, which has super strict rules. But your connection at home or in the office, that's more trusted, so you might put that in the internal zone, which has more relaxed rules. You're basically telling the firewall how much to trust each network.
Okay, now we're getting into a really big, really important concept, S-Linux. It's a completely different way of thinking about security. Standard permissions, as we saw, ask a simple question. Who owns this file? But S-Linux asks a much more powerful question. What is this program allowed to do? It doesn't care who owns what. It cares about what a web server is allowed to access, or what a database is allowed to touch. It's a shift from who are you to what are you allowed to do, which is way more secure.
And you have control over how it behaves. There are 3 modes. Enforcing is the default. It's on, it's active, and it will block things that break the rules. Then there's permissive mode, which is awesome for troubleshooting. It won't actually block anything, but it will create a log of everything it would have blocked, so you can see what's going wrong without breaking your system. And finally, yeah, you can just turn it off by setting it to disabled.
So there you have it. We've gone through the blueprint of the file system, opened the command line toolkit, met the gatekeepers of permissions, peeked into the engine room of services, and secured the fortress. That's the foundation. So the real question I want to leave you with is this. Now that you have these core pieces in your head, how does that change how you look at managing a Linux system? How does it change the way you think about security? Something to chew on. Thanks for joining me.